All right, 7th grade lesson 3.4. So go ahead and go to lesson 3.4 and work on the warm-up. This is the last lesson of this chapter. Factoring expressions. Okay, find the difference. This is your warm-up number 1. What does difference mean? Go ahead.
Subtraction.
Means subtraction. Very good. So you're going to write your answer in simplest form as a fraction or mixed number. So first of all, can I immediately subtract these?
Yes.
Yes. Why?
They both are the same.
Because they have a common denominator. Very good. So do the subtraction there. And then again on the second one, you're also subtracting, and you may have a mixed number as your answer. So I'll give you just a few minutes to do that, and then we'll continue. Okay, so factoring an expression. Somebody tell me, what is the definition of factoring an expression, Joel?
Factoring an expression is writing a numerical expression or algebraic expression as a product of factors.
Yes, algebraic expression is writing an expression as a product of factors. Very good. You can use distributive property to factor any number. So let me show you this example. Please put this in your journals.
Okay.
So we're going to factor 24x minus 18. This is an expression. This makes sense? We don't have an equal sign here. You have a variable with the first number and nothing with the second number. Make sense so far?
Yes.
We're going to use greatest common factor in order to factor this. You guys remember GCF?
Yes.
You sound sad. This is not good. So we're going to find the greatest common factor between 24x and 18. Okay? So, you guys remember how to make the factor tree? No?
Yeah.
Oh, yeah. No, six. I can already 6 and 4.
Okay, I don't want you to shout out the answer. I want to see how your brain does this. Because you need to be able to do this. I want to see the factor tree. Let me pull up my whiteboard. Yes. All right, so we're doing 24x, right?
Yeah.
Okay, so what is... Wow, that was intense. What is something times something that equals 24? Elliot?
6 times 4.
6 times 4. I always put the smaller number first. Okay, can I factor the 4 and the 6? Yes. What would be something times something that equals 4, Joaquin?
2 times 2.
Very good. And the 6? McDiego?
3 times 4.
2 times 3. Okay, can I factor any more of these?
No.
So then these are my factors. These 4. So 24x, the factors would be 2 times 2 times 2 times 3
Times X.
times x. Very good. Okay, so now we need to factor 18. Okay, what times what equals 18?
9.
No.
2 times 9.
Raise your hand. Sam.
2 times 9.
Okay. 2 times 9, 6 times 3 would have also worked. Can I factor either one of these again?
Yeah.
Which one?
9.
Okay, what times what equals 9?
3. Nothing.
3 times 3 equals 9.
I'm dumb. I'm dumb.
You're not dumb, you're just rushing. Slow down. Okay, I cannot factor any more of these, so the factors of 18, 8th grade, you're too loud, are 2 times 3 times 3.
No X because it's
Yes, and there's no x. So we need to find the greatest common factor between these two. Okay, we just found all their factors. So now, how do I find the greatest common factor between all these? We're going to circle the common prime factors. What is a prime factor? Sam?
something that cannot be divided into.
It's something that cannot be divided by anything except for itself or 1. So what are the prime factors out of these two? Joaquin?
All of them. This like I like.
The pair of 2
Oh, like that.
and the pair of 3. But see how this 3 and 2 don't match up, and this 3 and 2, you can only circle matching pairs. So I have a pair of 2s and a pair of 3s. Okay, what is 3 times 2? 6. So 6 is the greatest common factor, which is what somebody shouted out at the beginning. I think it was Izzy.
I thought that one of the greatest common factors was 6.
Yes.
Not the final answer.
No, it's not the final answer. It is the greatest common factor, which is what we were looking for. But now we're going to use the 6 in order to factor this expression. Okay? And factor, when you hear the word factor, guys, just think you're splitting it up. That's all you're doing. Come on, whiteboard. Go to the next page. So, if I have, a giant 24x evidently, minus 18. So now I'm going to factor 24x minus 18 by using my greatest common factor. What is my greatest common factor? 6. So I'm going to pull out the 6, and I'll have 6. 6 times what equals 24?
4.
So then this would be a 4x left. Okay? 6 times 4x minus, I pull out another 6. 6 times what gives me 18? 3. Okay? Now, I can write this nicer, because this is a lot. I can put both of the 6's way out here on the outside and factor the inside and just say 4x minus 3. Does this look familiar?
Yeah.
This should look like all the distributive property things you've been doing. You're doing reverse distributive property. That's what factoring is. Okay? So I found the greatest common factor that I could divide out of both terms, pulled it to the outside, and then rewrote the middle. Okay, so this is your final answer right here.
This is so much easier than what we were going to do.
Good. I'm glad. Okay, does everybody have this in your journal? Okay. I can wait a second. Let me go back in here. Once you got it in your journal, go and try it 1 through 3. Okay? And I'm going to pause the video while you work on that. Okay, so just to show you, hang on a second. All right, can you read number 4 to me real quick?
There's no number 4.
3. 4y minus 20, right?
There's 2.
Whatever. This is the one we're going to do.
Okay.
4y minus 20. Okay, so to find the greatest common factor, we go over here and we put a 4. What times what equals 4?
2.
Good. Now I do the same with 20. We had 4 times 5, right? And then 4 can be done 2 times 2. So then I list them on top of each other. So 2 times 2 is my 4 factors, right? Now I list the 20. I have 2 times 5, right?
Yeah.
Okay, so now you're looking for what matches. 2 times 2, so there's 1. 2 times 2, there's another 1. Oh, and this has an x, right? Or a y. Does the y and 5 match? No. So then all I do to find the greatest common factor is multiply these two. What's 2 times 2?
4.
So my greatest common factor between 4 and 20 is 4. Okay, now I was showing you how to factor out per term, right? We're going to skip a step and factor out a 4 from each term, but not write it confusingly. So look up here so you understand this. So if I'm factoring out a 4, I take this number and I say, what is this divided by 4? So what is 4 divided by 4? 1. Because 1 times 4 is 4, right? Then I just bring my y down. Now I look at this term. What is 20 divided by 4?
5. Wait, what is
And you're done. You don't have to put the 1. I'm doing that for those of you who yelled 0. Because 4 divided by 4 is 1. Now, can I leave this blank and just put the y? Yes. Okay, so I kind of skipped where you have the 2 sets of parentheses. Because I want you to look. All you're doing is you're finding the greatest common factor here. And then you take your 2 terms and divide it by whatever your greatest common factor is. Okay, and that becomes the new expression. And then you put whatever your greatest common factor was on the outside. Does this make a little more sense, maybe? It helps you skip steps, but properly. So glad you're paying attention. Everybody's looking down, not even talking to me. Yes, go. Fine.
Yes, ma'am. That's how you do it.
Thanks.
You're welcome.
Yes, ma'am.
At least my other kids are probably paying attention. Okay, put this in your journals. Pause whatever you're doing. Pull out your journal. We're going to factor 1/2 out of 1/2 x plus 3 halves. So we're going to write each term as a product of 1/2 and another factor. So essentially you're going to take this 1/2 and divide it from both of these. Okay, it's fractions, so it looks ugly, but it can be done. What is 1/2 divided by 1/2?
1.
Let's see how they do it. I want to do it my way. Is that okay?
Yeah.
Their way's okay, but I think you guys will understand it better if I do it this way. Okay, so we have, where's my pen? 1/2 x plus 3/2. So they already told you we're factoring out a 1/2. That means that's the greatest common factor. Okay, so we're factoring a 1/2 away from this. So it's like saying divided by 1/2. Divided by 1/2 from both of these. Okay? Well, how many times can 1/2 go into 1/2? 1. So my greatest common factor is 1/2. I put on the outside. I would write a 1 here, but I don't have to, do I?
No.
So what would I just write?
X.
The x. Wow, a giant x, evidently. Okay, and then on this one I got to do 3/2 divided by 1/2. Yeah, I guess because you saw the answer. I want to show you how to write it. When I'm dividing, I'm actually flipping and multiplying, remember? So then I get 2/2. This is 1. This is 1. I get 3/1, which is just 3. Okay, so then I put a 3 right there. Make sense?
Yes.
You may also use your calculator and say 3/2 divided by 1/2, and it'll give you 3. When you're thinking about it, guys, how many times can a half go into 3/2?
3.
Does that make sense? You hear the logic? A half and a half and a half equals 3/2. Just trying to help you with the logic there. Okay, good. Go do the next set of try-its. Journals. This is example 3. We're to factor a -2 out of -4p plus 10. So what is the number I'm going to divide out of my two terms?
P4.
P4.
What is the number I'm going to divide from my two terms?
10.
Guys, factor -2 out of -4p plus 10. What number am I dividing from my two terms? -2.
Woo!
The terms are -4p and 10. I'm dividing a -2 from both of those. Okay, whenever it says factor, this is the number you're dividing from both of these terms. Okay, let's see how complicated they did it. Yeah, I'm going to do it my way. It's fine. I mean, that's all, but they make it super fancy. Okay, so we have -4p, write this down, plus 10. Okay, my factor is what?
2, -2.
Very good. So I'm going to divide. Woo, I wrote the word factor with a mouse. -2. Wow, that's a giant negative. Okay, so I'm going to divide, almost, by -2 on both of these. So I'm going to put -2 on the outside. I'm undistributing. What is -4 divided by -2?
2.
Positive. And then you write the variable that goes with it. What is positive 10 divided by -2?
-5.
So this becomes a -5. Pay attention to that negative, guys. Because this used to be a positive. You see that?
Yeah.
But since I divided by a -2, it's changed it. Now, you can check your work. I can distribute. I can go 2 times 2, -4p, Negative 2 times negative 5 plus 10, right?
Yes.
So did I come up with the original answer?
Yes.
Then I know I've done this part correctly.
Okay.
All right? Go, go. Okay, it's example 4. Put this in your journals. A rectangular landing platform for a rocket is 60 yards wide and has an area of 60x plus 3,600 square yards. Write an expression that represents the perimeter in yards of the platform. Okay, so they want us to solve for the perimeter. It told us that it's 60 yards wide and the area is 60x plus 3,600. Okay? So we need to write the expression. So think about what are we going to factor out of this 6x plus 3,600? We're going to factor out the 60 yards. Very good. So if I factor out 60 yards, don't look at their mess, do it my way. What is 60 divided by 60?
1.
So then I have x. What is 3,600 divided by 60?
60.
60. So then I factored out 60 and I'm left with x plus 60.
That's the answer?
So far, so good?
Yeah.
Okay, so this represents... Oh, I need to close this. The width, right? 60 yards. We factored out 60 yards wide. So the length of the platform...
Whoa.
We have tigers in the hallway. Okay, listen. How do you find area?
Length times width.
Length times width. If I factored out the width, 60, what would be the length?
3,600.
The x plus 60. Because 60 was the width times length, which is x plus 60. Okay, so that's length. Now we got to put it into the perimeter formula. Do I need to write this down? I feel like eyes are glazed over.
Yeah.
All right, let me get my whiteboard. All right. So let's go over this again. Shh. Little pre-K kids. Oh my word. This is why I do not teach pre-K. They are fantastic when they are fantastic.
Bro, my sister bit me last night.
Okay, here we go. Hey, focus. So again, from our original, this expression represents area. Okay? Everybody follow that. And remember, the formula for area is
Times width.
length times width. Shh. Then they told us that how wide was it?
60.
60. So in order to find length times width, we factored 60 out of both of these. Okay? So that told me that 60, open parentheses, 60 divided by 60 is just 1, so leave the x. 3,600 divided by 60 is 60. Okay? Now this is still the formula for area. I just rearranged it a little, right? So when you're looking at this, what does the 60 represent? Width, right? 60 yards wide. So then this whole expression would be the length. Okay, now they're asking us about perimeter. How do I find the perimeter? 2 W's, because this is a rectangle, plus the 2 lengths, right? All right, now let's see. Write an expression that represents the perimeter in yards. So do I have any of this information?
Yes.
Yeah, I can plug in W. What is my W?
60.
60. And then what is my L?
60.
60x.
No, say it again.
60. X.
X
60.
plus, is 60x and x plus 60 two different things?
Yes.
You gotta be careful with your phrases, guys. 60x would be 60 times x, right?
Yeah.
Whereas x plus 60 is addition. So you gotta hear the difference. All right, can I simplify this mess?
Yes.
Yes.
Yeah.
What is 2 times 60?
70. I mean, 100.
Yes.
120.
120. I'm sorry.
120. Somebody needs lunch.
Yes.
Plus
120. 2x.
2x.
120.
All right, are there any other like terms?
Yes. Yes.
I'm gonna go over here.
240.
We have the 120 and the 120, right? So I'm just gonna rewrite 2x. What's 120 plus 120?
240.
240.
240. Do I now have an expression
Yeah.
Yes.
that stands for perimeter?
Yes.
Yeah, because this was perimeter, remember? Okay, so P equals 2x plus 240. So all we did was solve for W and L, so that way I could find my width and my length from the area equation. Once I had those, I could plug those into the perimeter equation where the W and the L go.
Okay.
Does this make sense?
No, not kind of.
Well, ask me a question.
I don't know.
What part is confusing?
Exactly.
Okay, so we're going to go for it, and then when you have a question, you'll raise your hand.
Yeah.
Again, we had the original area equation, right? They told us this stood for area.
Oh, I did.
I know.
That's literally all I had to say.
Yes.
Okay? And then they told us what the width was, 60 yards. So that's why I factored out 60 so that I could find out what L equals.
Yeah.
Because area is length times width. There's a multiplication right there. Once I figured out what W and L were, I could put it in my new equation for perimeter and plug in what W equals and what L equals, and then just simplified. So this is the perimeter. Okay? I hope y'all caught on. Ask a question. What's your question?
So in the beginning with the 60x plus 2,600.
Right.
The thing below it is 37.
So what we did is you had your original equation, 60x plus 3600, and they told you that stands for area. We needed to find what the length of this rectangle, because they told us it was a rectangle. That's a terrible rectangle. They told us it was a rectangle, and the area, how do you find the area of a rectangle? You do width times length. So they told us the width, right here, you see it, 60. So we knew this was 60. But we didn't know what L was, right? So up here, if I factored out of this expression whatever the width was, whatever's left is L. So that's why we factored out a 60. And the 60 means it's the W, and then the rest of it is L. Because this, you can think of this as width times length. So now I could say, I could go over here and I could have written W equals 60. And length equals what?
60.
No, x plus 60.
Very good. So now that I have W equals 60, that looks like a B. I'm not sure that made it better, but whatever. And length equals this. Now I could find the perimeter, because the perimeter of a rectangle is W plus L plus L. Or 2 W's plus 2 L's. So then I just took my W and I plugged it in where the W is, and I took my L, which is the whole expression, and I plugged it in where the L is here. See how it's here? And then I just distributed because I wanted to simplify. Does that help?
Yes.
Okay. So if you have any questions, let me know.
What did you do 3,600?
We factored out. We divided by 60 to factor out a 60, so that's why you got 60 right here. Good question. Any other good questions? Yes. Okay, do you have any questions on this example? Until I'm done with this, wait for the next thing. Any other questions on this example? Okay, then you need to finish all the way through self-assess number 17. That's the end of it, okay? This is due tomorrow, so make sure if you don't get it done by the end of class or the end of day today, then you take it home and work on it tonight, okay?